Welcome, everyone, to the NUSAI Health Community. This initiative, brought to you by the Alice Lee Center for Nursing Studies, ALCANS, at the Yon Lu Line School of Medicine, National University of Singapore, NUS, is part of the NUSAI Community of Practice, NUSAI CA. Our primary aim is to educate healthcare professionals on the application of artificial intelligence, AI, in healthcare. This project is funded by the NUS Center for Teaching, Learning and Technology, CTLT, Teaching Enhancement Grants, TEG, FY 2023/2024. Within our learning community, we offer foundational AI knowledge and skills tailored specifically for healthcare professionals. We also promote collaboration and share AI-integrated teaching plans for healthcare education among local and international participants. Allow me to introduce the dedicated members of the NUSAI Health Community who contribute their expertise and enthusiasm towards leveraging AI for the betterment of healthcare. We also extend our gratitude to NUS Center for Teaching, Learning and Technology, CTLT, for their invaluable contributions towards funding and publicity, which have been instrumental in making our community thrive. But that's not all. Brace yourselves for our monthly webinars featuring expert speakers delving into AI and its myriad applications in healthcare industry and education. Additionally, our platform serves as a hub for learning resources and event updates, ensuring you stay updated of all the latest developments. And if that's not enticing enough, our YouTube channel hosts a wealth of training courses focused on AI in the healthcare industry and education. Don't miss out on the opportunity to be part of this dynamic community. Subscribe to our channel at NUSA Health Community and visit our website to stay tuned for exciting updates on our upcoming events.
Good afternoon, educators, researchers, and interested participants. Thank you for joining us for a webinar organized by NUSAI Health Community, National University of Singapore. I am Piani Yobash, a main facilitator of the NUSAI Health Community, and I will be a moderator today. It is my honor to introduce our speaker, Associate Professor Khoo Eng Tat. He currently serves as the Assistant Dean, Research and Technology at the College of Design and Engineering. He is also an Associate Professor and the Area Director, Outreach at the Engineering Design and Innovation Center. Prof. Khoo directs the Immersive Reality Lab with research and teaching interests in product development, virtual and augmented reality, conversational AI, and human-computer interaction. He has many research projects and publications in this area. So for today, he will deliver the webinar AI-powered, virtual, augmented, and mixed reality for immersive learning. Please join me in welcoming Associate Professor Khoo Eng Tat. Prof. Khoo, please go ahead.
Good afternoon, everyone. First off, thank you, Professor Piani, and also Chevons for the invitation. And I can start now. Maybe I share my screen.
Please go ahead.
Can you see my screen?
Oh, definitely. Yes, perfect.
Okay. Sounds good. So let me just do that. So welcome, everyone. So today I'm going to share a few examples of some of the projects that I've worked on using AI-powered mixed reality for immersive learning experiences. And I'm Eng Tat. I'm just maybe a brief introduction of myself. I'm currently Assistant Dean as Research and Technology at the College of Design and Engineering. I'm an Associate Professor at Engineering Design and Innovation Center, and also I have a joint appointment with Electrical and Computer Engineering. And I think besides directing the lab, I also work closely with the industry as well as a founding member of HoloMedicine Association, and previously as the board directors of Asia VR Association. So about building the community between researchers, industry partners, and all this coming together to grow
He has been conceptualizing.
Right. So yeah, and also formally, actually, before I joined NUS, so I did my bachelor and PhD in electrical computer engineering in NUS. After that, I went on to be a R&D director for a US AR/VR company funded through Economic Development Board (EDB). And then I started my own company. I was briefly about a year in VC doing investment. and before I come back to NUS. So this is almost 8 years back coming to NUS. So I'm going to share some of the work that I do when I first come back to NUS. And one of the first thing I do was to establish a NUS Immersive Reality Lab. With the visions of inventing a better future by increasing productivity and capabilities through immersive technology like AR, VR, XR, and also generative AI. Right, so we are a very applied research lab that we work very closely with industry partners, domain partners, for example, with medical school, with the hospitals, with the nursing school, so that we can actually deliver these solutions. And we work on virtual reality, augmented and mixed reality simulation development. We work on a generative AI language model. We host our own server. We have our own custom LLM as well, and we work on computer vision, like trackings of the objects, for detections of the medical instruments. We do machine learning. And also, I think very importantly, we look into also user experience and interaction, because when the technology is developed, I think we need to make sure that we also evaluate how it's being used by the students, by the healthcare professionals. So we do a study on that as well. Right. So I think it's interestingly, for the last 20 years, my work has been in working on convergence of realities, right? I first started my PhD designing mixed reality games for elderly and children, right? So it's more starting for entertainment. So when I first finished my PhD, go into industry, I developed simulations for oil and gas training. So we developed virtual reality to train oil and gas operators. And we also do augmented reality. When they go onto the actual plant, how can they continue using the augmented information on the ground to help them. So I think it's very interesting moving in the last 20 years, the development from virtual reality where everything is virtual. We create like similar to games and virtual environment simulations, we create virtual things. But VR is getting very real as well, because now we are not talking about just virtual reality. You can actually interact with the real user. We have a full tracking of hands, tracking of our facial expressions, and and in some cases we can also incorporate haptics. So the virtual reality is getting very real, right? On the other end, where we overlay digital information into the reality, which is called augmented reality, right? This is where we have the goggles, the AR goggles, Google Glasses, or HoloLens, for example, able to overlay 3D environment into the actual setting here, right? So, and this is actually very believable. You can see on the left here, this is the project we work with the ophthalmology for eye examinations and all this. And this is actually a virtual patient. So we can actually project a virtual patient in a clinic when the patient is not there, but the doctors can still use the actual instrument to work on the virtual patient. And this is where we can allow that kind of a real environment with a virtual human, and we can actually interact seamlessly. I think interestingly, in the next I think in the near future, in the next 5-10 years, I think the line between virtual reality, mixed reality will be very blurred, because I think all these devices do have capability that not only a VR, but it become the MR as well. Many of the devices today, for example, Quest 3, Quest Pro, we have Apple Vision Pro. These are devices who are VR, but they have the video through capability as well, right? And so I think those are blurred. I think in the future, I think in this presentation, when I meant Metaverse, when I meant immersive reality, when I meant mixed reality, I just mean a version of either a VR, MR, or AR. It doesn't matter, because I think in the future, it will be the same thing, right? It's all converging. And what is interesting here is that also, I think in the last few years, the explosion of a generative AI and large language model, right? A lot of this research, when I work on with our partners, we started off without the Gen AI or large language model. But over the time with this a very powerful tool, I think we can look into how we can create a virtual human augmenting using large language model to understand what the trainee go through, the context of it. And this is where the simulations are able to even provide a greater context to the users. Right. So there's a bit of background of conversational reality and generative AI and large language model. I think this is very, very exciting space. I've been here, working in this space for over 20 years. I thought this is exciting. I think the last few years have a game changer. I think it's going even faster. Right. So I think I'm going to share a couple of projects here. One of the projects maybe I'd like to start off and saying that collaboration is really challenging. When I first came back to engineering, before, of course, engineering is merged with the design, so it's called College of Design Engineering now. When I first came back, from our CDE side, we have we know that this simulation is going to do a lot for training, right? I was looking into medical training. It took us a long time before a collaborator come back. Of course, everyone is busy. Our healthcare professionals are very, very busy. And one of the first person to go back to me was Prof. Mary Ruff. She's a ONG, a very senior gynecologist, ONG professor. And she came back and said, hey, the dropping birth rate, limited training opportunity for our medical students. Can we use virtual reality for training? And we knew we can do it. And it took us almost 4 years to develop this. So we started getting some engineering students, to learn how to build simulation. And then we started to get a requirement from Department of Obstetrics and Gynecology about the what is needed in terms of the training. What are the gaps? How do we bridge between what we train in a classroom and a mannequin and what is in the operating theater, right? No, delivery suite, right? So DS, right? So how do we bridge the gap? And then we came out with the virtual reality solutions that we facilitate them learning the procedures, because today medical students don't have that much opportunity working on simulation, right? This is where a typical environment on the right is where the mannequin training is, standard training for the medical students going through the ONG posting. And then on the left, this is what we have developed for medical school. So all the year 4 medical students going through ONG posting at NUH will use our system on virtual reality systems for training learning how to deliver baby. So we have developed a few simulation from the natural birth labor stage 2 and 3. We have developed the simulations on the whole procedures on delivering baby, the placenta, and then we also come up with a few different emergency procedures, for example, shoulder dystocia and a few procedures. But this sharing here is mainly on the natural birth delivery training, right? So, and we have developed the simulator. And this is based on a study we conducted 2 years ago, for normal vaginal delivery, conducted at a large-scale empirical study of 117 medical students going through NUH posting. What we find is that there's a significant improvements in the knowledge core with using the VR as compared to the mannequin. So we're comparing VR and mannequin and look at what is the delta of the knowledge gain through the simulation. And virtual reality students who went through the virtual reality actually score higher, the data score. And this is very, very promising in terms of the results. And so I think that's a bit of background I'm mentioning, challenges is securing the ONG training opportunities for students, because, the patient acceptability nowadays, the mothers giving birth also don't want too many trainees in the room. And there's also a gender bias as well, from what I learned, because male students sometimes don't get that much training opportunity as compared to female students, and also the physician's reluctance towards the student involvement. And then at the same time, there's a limitation in the mannequin-based simulation in ONG in terms of the manpower and equipment constraint, how to set up that, and varying level of learning outcomes among students. All right. So I think in this research, we look at how do we incorporate virtual reality in childbirth delivery training for medical students, and that we can influence the learning outcome. And we also wanted to study what is the acceptance of technology, because we know that when we introduce a new training modality, it's not a guarantee that they'll like it. All right. So and we have a very interesting results from this research. And this is whatever I'm showing here. This is like 2 years ago. We have since worked on add-on things I'm going to mention in a bit. But this is how it typically looks like in a virtual reality environment. We created the delivery suite, with the whole environment, and then the students have to key in their IDs, for them to start doing simulation, and then they will learn to deliver the whole. They first understand the tool familiarization with the whole environment, all the tools that they need to interact with. And there's some quizzes in there. And then they will learn the whole procedure of delivering babies. And, I think earlier you can see that here, this is where the students, so we have the use of virtual hand, and then to guide the actual students how to maneuver and delivering the baby. right? So this is what we have built. And this is a study. We have actually split the students into group A and group B. The first group actually go through the VR simulation first. But before they do the simulations, we get them to fill up the simulation knowledge quiz. So we want to know what is the level of knowledge before they go into simulation. And after they've done the simulations, we do a post quiz, right? So then we want to measure how much have they gained in their knowledge in delivering baby, right? So and we did that for the second group as well, for group B, pre and post quiz. And this is where we compare the delta of the knowledge gain. And of course, then after they do the first one, then they go through the second modality. So the VR group for the first group, they will then do mannequin for the second round, the second period. Whereas the group B will do a mannequin first, followed by VR simulation. So and this is where we look at we administer the before and after knowledge quiz, and it's 10 multiple choice questions, maximum score 100. And these questionnaires were developed by the ONG educators. We wanted to measure the students' understanding on the stage 2 and 3 of a label based on the year 4 medical school syllabus, right? And for our results shows that this group that use VR actually attain a higher delta in their knowledge gain, right? And 24.9% higher than mannequin simulation session. And this is a very significant result. However, when we probe deeper into the feasibility questions about how they like, the confidence of using it, the usability, the enjoyment, is interestingly the results on the other way, right? So the students still very much preferred, mannequin over VR. So that's interesting results, right? You have on one hand, students who gain a significantly better learning outcome in terms of the knowledge gain, right? But then at the same time, they still liked very much, for example, they enjoy using the mannequin training better. They felt it's easier to use and they're more confident in the mannequin training. So this is a very, very interesting results that I think is very important when we are looking at designing new modality for education. Not that it only works well for them, but how do we get acceptance and for our users? And this is very important. And this is very surprising results, but I think it's great for us to understand a bit more. And from there, we understand that VR training is least favored on its own, but the combined mannequin and VR approach is the most preferred. So actually, the students mentioned they like to have both training. And this is what we do now in medical school for ONG posting. We actually have both the training, right? Both the mannequin and VR. The two reasons why participants favor mannequin over is that they like the tactility because they're used to the mannequin. I guess the context here is that almost every specialties train a mannequin, right? So they are used to that modality and feel comfortable with the tactility and also the engaging tutor. In a VR environment, there isn't a tutor. It's a virtually completely briefing. So that's missing this element, right? And maybe I'll just share that. From there, this is the result 2 years ago. And what we have done so far is that we continue developing. So we are very lucky. We got some teaching grants and to support the project. So we further developed mixed reality system. So now I'm not showing here, but we are writing a manuscript now on mixed reality, meaning that we overlay the VR onto the mannequin. So the students are now training with the mannequin plus the VR in a mixed reality environment, right? So we are now have progressed that. So we have conducted a study this year and we are writing a manuscript on that. Yeah. And yeah, so I think on the other hand, I think very interestingly, besides the simulation of virtual reality, mixed reality, which I'm very, very passionate about, I think another area I'm very, very interested in is conversational AI, right? Talking to an AI agent, right? And this is my one of my work during my PhD as well, creating Confucius computer, a conversational agent that you can talk to virtual Confucius. Bear in mind, this is 2009, 2008, 9, 10 period. So this is pre-large language model, pre-ChatGPT. So this is a combination of techniques that I've used earlier was more rule-based conversational agent. And then on training, actually in this project, I work with the Chinese Studies Department, getting the Confucius Scholar to help to tag the weights of the different knowledge base and label them. And we use that as a training form, and I deploy more of information retrieval techniques to reply the most relevant quotes from the Confucius Analects, right? And these are all done conversational AI. And I want to share that because I think we come a long way, right? And I always thought, a lot of us who think that, hey, now it's just ChatGPT is so easy. I think we should appreciate how far we have come in the last 20 years in this journey. It's just that, when I first started working on virtual reality, the headset is like $50,000. And if you're not careful, you'll break your neck, right? So, and it was such improvements. Today, we can have a $500 headset that is 2K resolution, each eye stereo. I think we come a long, long way, right? This is another one I'm very interested in, conversational AI. And one of the first project we work with on conversational AI is we work with so I just have to mention that every project I share here, we have a very strong supportive collaborators. Like in ONG, I started off working with Prof. Mary Ralph, and then I continue working with Dr. Arundhati, with the full support from Prof. Mahesh, the ONG, head of ONG. And in this case of orthopedic training, I work with Prof. Gabriel Liu, and on the needs of creating AI clinical assessment, right? So how do we create a virtual patient who have some maybe a back problem and things like that will allow the students to be able to talking to the patient in terms of understanding the symptoms. And so this is really trying to replace or try to complement the standardized patient. So we wanted to give the students more exposure to standardized patient in the AI form before they actually work with the standardized patient, which are so standardized patient in medical school settings is a set of actors that the medical school hire and train them to learn a certain scenarios in that they assume certain persona of a patient and then able to exhibit certain symptoms so that they become a proxy for the medical students to train with them so that the students can actually can learn, and also the educators can assess their understanding in that particular area. So this case, we actually work with the orthopedic. We actually collected data from what the typical training material they pass to for the standardized patient training. We use this material to train our AI. And when I first started this is based, I think, 2019 or 20. So this is actually pre-LLM as well. So we use tools like, for example, RASA, which have a natural language processing understanding. But then it's not as end-to-end as what we understand today, like ChatGPT or LLM, where we can just have a full understanding of language. Back then, it's like we need to have a modular understanding of the intent and all these things so that we can label, so that it can return the right kind of a context. So it's a very much modular form of a natural language understanding and AI, right? But we're still able to come out with a very, very convincing use case. We shared these results in the AI in Education conference back in 2022. And then, so this is where we created a few different personas of AI patients that the orthopedic students can actually interact with them, right? So I think maybe I'll just show you a bit of environment, how it looks like.
When
this
this pain starts.
My leg has been like this for 6 months.
Can you hear the audio?
Yeah, we can hear.
Okay, so maybe I just do a bit of that. So these are
When this pain starts.
My leg has been like this for 6 months. It started back when I was working and has gotten worse since.
Ask what's Nadi's occupation.
Hey, I'm going to start raising the right leg. Let me know when it starts to hurt.
Okay, sure.
So you can see here, this is a virtual environment that we created. Not only we have an AI agent that can act as the patient, a standardized patient. You have a natural language conversation, just like what your medical students would do with the standardized patient. More than that, we allow physical examination as well, because they can perform the examinations with the AI patient. At the same time, we can also allow multi-user, all right? So we can have instructors and other students joining in. You can see this here. These doctors, these agents are actually users who join through remotely, right, through the VR. So we can have multiple sessions that we can have real players joining in virtual environment, and we can have AI patient. And we can, of course, also have AI other players, other medical doctors as well, which we explored in other situation with different departments. Yeah, so I'm going to, overall we have developed over 20 simulations with medical school, with the NUH. I'm not going to share all of this here. If any interest during Q&A, I can actually share a bit more details on that. Yeah, so maybe I'm just going to move on so some of the projects beyond the medical school training the students. I also work with NUHS on developing mixed reality simulations. With Dr. Cao Yuja, with my PhD student Kian Wei. We look into developing like point of care for for ultrasound. Right, this project we look into using ultrasound, but making 2D ultrasound into a 3D mixed reality ultrasound. So what we did is that we actually the current drawback of 2D ultrasound is like highly user dependent, right? If you have a very experienced clinicians, you can actually see a lot of things. But if you have more junior clinicians, maybe a lot of artifacts, all these things are missed or misinterpreted, right? So it's difficult interpreting 2D image and like out of plane motions and movements. So I think what we look into addressing this is that we take slices of the 2D ultrasound, we use AI to reconstruct the 3D volume and project it back. Like for example, you do a thyroid scan, the surgeons are able to see the scan and what is looking at directly into the anatomy of the body, right? So we have work on this on the thyroid. We also look into the liver reconstruction. So we are looking into using ultrasound for point of care at the bedside diagnostic, right? So this I think has a lot of implications in terms of making decisions, instead of looking for ultrasound and then send for CT scans or MRI, we can probably make a lot more decisions with the more detailed, upgraded 3D ultrasound, right? And we have developed a unique tracking for the probe that we can actually achieve a very, very high level accuracy, up to 1 millimeter accuracy on the probe tracking, that we can actually do a reconstruction of the data. And this table shows our results, right? And yeah, so we have done the reconstructions, and then we can visualize the key structures all at once instead of plane by plane. And we can also have a procedure guidance during the point of care bedside diagnostic. And this is where I think we are looking at not just training medical students, but also how do we train medical or assist medical professionals when they are actually performing the task as well. So this is moving from just the education into the clinician training, right? And another this project is featured as well, how we use mixed reality tech to deliver faster ultrasound scans. Yeah, you're interested, you can look at some of this article here. And another project that we work on with NUH with Dr. Cao and my PhD student Kian Wei is on HoloVein, like vein finding and projection. So we use mixed reality, the HoloLens, which have infrared cameras. So which can pick up the vein signals, and then we use AI to do segmentation of the veins, and then we project this vein back to the field of view of the user, the clinician. So when the clinicians are doing IV cannulation and all those things, it's easier to identify the veins. And I guess some of us do have a bad experience of having to have a few more pokes. Hopefully this will make the process less painful, right? So and advanced, so we leverage on advanced sensors on HoloLens devices, wide field of view, and we directly integrate into mixed reality. So this is actually hands-free projection. So meaning that when the clinician varies, you can just perform your task normally, whereas you have additional, augmented data through the AI on the veins, or in the earlier project on the ultrasound is the volume or the imaging that overlay onto the anatomy, right? So and this is where I think it's very, very interesting how we are still now in a process of doing studies with the efficacy of such a solution. Yeah, so I thought maybe I would stop here with some sharing of some of the work. But if you're interested, there's a link to my website. I do have quite a number of other projects that we work with the medical school. So happy to take more questions, and then maybe you can discuss a bit more. Yeah, and looking forward to some of the potential collaboration as well with some of you. Yeah, thank you.
Okay, thank you, Prof. Koo, for the wonderful presentation. That's wonderful for sharing.